to, all right, reteaching section 2.3. Let's write our y equals mx plus b's from the graph. So the first thing that I'm going to do for each of these is I'm going to go identify the y-intercept, because really the y-intercept should be the easiest piece. Where does the line hit the y-axis? The y-intercept is where does the line hit the y-axis? And then this one is at 2. Any questions about any of those? Where does the line hit the y-axis? That's it. I mean, look, there it is. And then, Mr. Milling, how do we have to think about slope in a graph? You got it. I find 2 places. I'm probably going too quick right now. Got to think slope is rise over run. What's up, Jordan? Okay, good. I got to think slope is rise over run. In each of these cases, I just found a place where like my y-intercepts in each case is a perfect point that goes through the crosshairs. I'm going to find another one. You guys notice how I'm not picking out this place on the line because it's not going through the crosshairs. Like I went right up here. Picking out a place where the line goes right through the crosshairs because I want to be thinking rise over run. How much did I just go up?
3.
No. 2 over. So my slope is 2 over 1, so it's just 2. So what's my equation for this line? That's it.
Wait. Okay, what equals 2 over 1?
The rise of the line?
I mean,
from
like in the paper, it says equals, but it don't show, like,
your slope. Rise over run. So then let me go here. You guys okay with this point? Save it, Tazon. I knew it was you.
See?
Somebody sounds like my puppy right now. What's the rise of the line? What's the run of the line? -2. I got to go that way. So what's 2 divided by -2? -1. How about final equation on this one? Y equals -1x plus 2? Nope, not plus 2. Well, plus -2. So how about better yet? Y equals -x minus 2. Whoever's making the noises, seriously, just stop. Like, do I have to say this? So y equals -1x plus -2. Better yet, -x minus 2. Your slope's got to be negative when your line's slanting downwards. And then rise over run here. Ooh. Oh, here we go. It's pointing right at this little one right there. So for this one, let's do slope is rise over run. Up how many? To the right how many? I don't need to simplify that. So my equation for this line is going to be 2/3 x plus 2. So in each case, I started out on the y-axis with my b value. Hopefully this is a lot more straightforward and like clicking. Like I know, and I said this last week, that you may not have mastered this in Algebra 1, and that's okay. This week we're going to get to mastery. We have to, okay? Questions before I move forward? Oh, turn your packet to the next page when you're ready to go on. We're going to get to mastery this week. Okay. So, we're going to do some graphing, and I'm going to use the same approach as, I'm going to use the exact same approach as the problem example. And before I even go to draw the graphs, I'm going to do a bunch of the work, and I'm going to actually put the work for these problems right on this page. Now, I'm going to go through the same process as the example problem above. And to draw a graph of each of these equations, it's like undoing what I was just looking at. I want to be able to put the y-intercept on the graph, and I want to be able to count rise over run from that point. So what I'm going to do in each of these cases, and you can follow along with me, is I'm going to put these into, so this is 2y equals 3x plus 6. I'm going to solve these for y. I want this to be a y equals so I can see what that y-intercept is, and I can see what that slope is. 2y equals 3x plus 6. I added 3x's to both sides. I'm trying to isolate or get y alone. And then my next move would be divide every piece of this equation by 2. Everything has to be divided by 2. So I'm getting this to a y equals 3 over 2x plus 3. Now I am super comfortable leaving that as 3/2 because I want it as a rise over run. I want it to be a rise over run. What questions do you have right now? Isaac? Behind it still, it doesn't even matter, just make sure the number stuck to x is what you use as your slope. So what I'm getting from Isaac is he came over here and wrote this as 6 plus 3x, and then he would have finished as 3 plus 3/2 x, which is fine. This is still the y-intercept, this is still the slope. Cool? Now, grab your graph paper. I think it only makes sense. So we're going to go to our graph paper. My y-intercept is 3. So I'm going to just do a quick little xy axis. Not too big, not too small, in the upper left-hand corner of my paper because I've got to graph a whole bunch of other stuff. And I know my y-intercept is 3, so I'm going to start my graph by putting a point on the y-axis at 3. And then from there, I'm going to consider my slope to be, so my b was 3 for my equation, my slope is 3/2. So from my y-intercept of 3, I'm going to go up 2, 3, to the right 2. And I can keep following that pattern just to get a few other points. I could also go down 3 and to the left 2. Just follow that 3, 2 pattern. And down 3 to the left 2 is the same as negative 3 over positive 2. So again, I started my graph on the y-axis at 3, and then use my slope idea to count up 3 to the right 2, and then I just kept following that pattern to continue my line. I'm going to go to problem 19 next, just because it's underneath it, and I'm not sure I want a video of every one of these graphs. That one just took 7 minutes. I'm going to go to 19 next, and I'm going to start putting this into slope-intercept form as you finish your graph. Negative 2x. No, maybe I could have done this differently, but I didn't. Oh well. Equals 4y, plus 4y equals 3. All right, hopefully you can move away from your graph and join me here now at my solving for y for 19. Join me here in my solving for y in 19. 4y equals 2x plus 3. Perfect, thank you. I realized once I started manipulating that I could have moved it around a little bit differently, but that's okay. Sure. So I added 3 to both sides. I'm trying to leave that 4y alone. Once you get this down, maybe somebody could tell me, is today the 2nd, you guys? Yes. Maybe somebody could tell me what I would do next. I kind of stopped for you guys to catch up. As you're writing it down, think about what I could do next. Divide by 4. Yep. Oh, I don't like this slope y-intercept. I don't like the y-intercept being 3/4. Maybe we won't graph this one. We could, but half x plus 3/4. I don't need you guys to graph this one. I don't like the fact that it's 3/4. Our counting would be a little weird. We'll graph another problem. It says graph each, but that's ugly. I want it to be friendly for you. You'd have to go to your y-axis at 3/4, put a point there, and then count up 1 and estimate. It's all going to be an estimate if I graph it. So let's just do this. Slope is what? A half. And the y-intercept of this would be 3/4. And if I had to graph it, I would use that. We'll just leave it at that. I'm going to go up to number 17. We'll graph 17. Join me here. To get y alone, what am I going to do? Take x away from both sides. So that's going to leave me with 3y equals, let me do this, 3 minus x, like Isaac was talking about. What if I don't have the x out front? It's not going to be the end of the world. What's my next step going to be to get y alone? Divide by 3. Every piece has to be divided by 3. Interested in if anybody can simplify this one before we go graph it. What's this 3 over 3 going to give me? And what's this x over 3 going to give me? What's the slope? It's negative. Yeah, it's negative 1/3. Notice how I'm dropping a 1 in front of x, so I can pull that fraction out there and think about the y-intercept as negative 1/3. Now that y-intercept of negative 1/3, let me go over to my graph paper now. Dropping in another, it's got to hit the y-axis at 1. Okay, so I'm going to put this one just underneath, just make sure that they're labeled. I'm trying to keep mine in my video screen, so make sure they're labeled. I'm going to clarify something about negative slopes here as we do this together. Now in this one, my y-intercept is 1 and my slope is negative 1/3. Now here's this thing about negative slopes. You got to put either, so this is going to be either put the negative in the top of the fraction or put it in the bottom. It can't go in both. So I've got to think about this slope as either negative 1 over positive 3 or positive 1 over negative 3. Any way I want to do it is fine, but it can't go in both. I'm going to start my graph at the y-intercept of 1. I'm actually going to use this one. Down 1, right 3. If I use this one, it would have been up 1, left 3. Still on the line. Either one, but not both. What questions might you have on this one?